These are the rocky shores of the Izu Peninsula, near the city of Ito, about a 2.5-hour drive southeast of Tokyo. Marine biologists have come here during the spawning season to film and observe the breeding activities of a variety of marine animals. Below the surface of the restless sea, there are endless varieties of creatures living out their existence, eating, growing, surviving, and most of all, reproducing. Millions upon millions of eggs are released into the marine environment, yet the population of the undersea world seldom fluctuates much because the life process is neatly under nature's control. However many thousands of eggs may be produced, there are chances for only a few young to survive and become adults. One species may produce thousands of offspring, while others have only a few babies. The numbers are dependent on how well protected the eggs are for survival. The divers have already found the first egg to begin their long study of the spawning season. This egg was laid some time ago by a bowhead shark. It has a unique design that protects the developing embryo. When the egg is first laid, it's soft, and the spirals are flat against the casing. As the spirals stiffen, they take shape, protecting the encased embryo from damage while allowing ocean currents to propel it along until its twisting motion wedges it into its final resting place. This baby bullhead shark broke out of its egg case only 10 days ago, after spending an entire year developing into this miniature version of its parents. When it was hatched, it was completely equipped for survival, and most especially, able to protect itself from danger. A shark's body is boneless. Its form is simple and relatively unsophisticated in the complex world of sea creatures. Sharks are considered to be primitive because there haven't been any substantial evolutionary changes in the species since it first appeared in the world. Yet, unlike most fish who haphazardly drop eggs and sperm separately into the sea, sharks perform internal fertilization. And unlike most fish who leave their developing embryos defenseless, sharks either bear live young or produce protectively armored eggs. So, unlike other fish, the shark has managed to survive unchanged since the beginning of time. The most vulnerable period of life is in the early developing stage. Once an animal becomes a miniature version of its parent, it has greatly increased its chances for survival. This baby trunkfish may be smaller than its parent, but its protective defenses operate just as effectively as the adults. The adult trunkfish, or boxfish as it's also known, is like a living armored tank. The soft body is encased in a hard shell, open only at the fins, the end of the mouth, and the eyes. Even the gill openings are covered, and only the rapid beat of the fins keeps fresh water circulating through the armor. Like the parent, a baby trunkfish is incredibly agile. Once it's reached this stage, a baby fish has beat the odds and is likely to survive long enough to generate its own children. Early in the process of embryo development, the odds are really stacked against survival. A hard-shelled creature doesn't form its protective armor until it has passed through several progressive stages. A turban shell carries its armor on its back, and it also collects camouflage to make itself almost indistinguishable from its rocky home, no matter which side you look at. The only evident features are the white lips of the shell that surround the main body opening. The white substance beside the turban shell's home are newly laid eggs. Like most slow-moving snails, the turban shell dispenses folding ribbons of eggs suspended in a beautiful but distasteful gelatin coating that discourages predators. Eggs are found anywhere and everywhere. In fact, there are only a few species which choose any particular spot to deposit eggs. Most are simply left to drift in the ocean currents. The keen-eyed divers are on the lookout for any examples of egg deposits, like these eggs left by the cuttlefish, a relative of the squid and octopus. The white tentacle fingers of soft egg casings are attached in clumps to a growth of seaweed. Some species of cuttlefish place their eggs individually in protective coral crevices, but most produce these long egg strings which they leave undefended, because spawning marks the end of a cuttlefish's short life. However, the eggs of the squid and octopus are kept in caves, and the mother remains to watch over them. These are egg casings of the short-finned squid. The divers are going to distract the mother so they can take a strand for a closer look. The mother squid comes out to defend her eggs from the intruders, unaware that the divers want her clear of the cave so they can collect some of her eggs. The short-finned squid is not encountered very often, and it's only because of the eggs she defends that she stays around. Several hundred eggs are inside each long string, and as the embryos develop, the string shrinks, its thin membrane stretching and bulging around each individual egg. Watch this amazing sequence as the new young squids break free to begin their new life. The short-finned squid guards her developing embryos until they hatch, while most other marine creatures leave their eggs to fend for themselves. The squid lays thousands of eggs, yet other creatures must produce millions. If just one species had all of its eggs survive to become reproducing adults, it would take only a few short years before every square inch of ocean was taken up by that single species. When a fish lays millions of undefended eggs, only thousands of her embryos will ever survive to hatch into tiny larvae. And of those thousands, a few hundred might live to develop into miniature adults. But of those hundreds, only 10 might endure through adolescence, until finally, after millions of eggs, only 2 are left to begin the reproductive cycle all over again. The average population per species in the ocean world barely fluctuates. The end results are consistent. 2 offspring will survive to replace 2 adults. The game of numbers is intricately related to the amount of parental care undertaken by each species. And although the norm in the fish world is for embryos to be left to develop on their own, there are several interesting exceptions. The elegantly striped cardinal fish, for example, has developed one of the most intriguing forms of parental protection. The underwater biologists are anxious to locate cardinal fish, which are still in the midst of their spawning activities. After spending a considerable amount of time patiently searching, the divers have found the rocky cave home of a cardinal fish couple that has already laid their eggs. The male cardinal fish is responsible for protecting the eggs, and he does this in an incredible fashion by storing them right inside his mouth. Notice how bloated his mouth is. It's full of developing embryos. After the eggs have been laid and fertilized, the male cardinal fish gathers them up in his mouth, protecting them in this way from any harm for the full 10 to 14 days they take to hatch. During this time, he's not able to eat anything, and his main chore is to keep fresh water swirling around the eggs. The male cardinal fish develops a unique bond with his offspring. The care he takes in making sure that the eggs are properly incubated is far more advanced than the majority of marine creatures. Though the youngsters will face a harsh world, cardinal fish begin their lives under the watchful eye and gentle care of their parents. The divers are going to try and capture a mouth-breathing cardinal fish so that they can get a closer look at the events surrounding the hatching of the eggs. They hope to take the cardinal fish to a laboratory where they can observe its behavior. Some male cardinal fish have been known to carry as many as 20,000 developing eggs at a single time. As the father swirls fresh, oxygen-rich water through his mouth, we get a good look at the solid white mass of eggs that he's incubating. The divers are crouched and ready to catch the cardinal fish and put him in the waiting plastic bag. As soon as they've netted him, divers put him in the bag in case he panics and releases the eggs before they can get back to the laboratory. And that's what's happening. The cardinal fish has ejected the egg mass into the bag. Without the father's body warmth, they could perish in the open water. So the divers use their light to keep them warm, hoping that the father will take the offspring back into his mouth. The male cardinal fish is much too nervous about being out of his cave home to turn his attention to the eggs. You can see the vast numbers of eggs that were compressed into the father's mouth. There are over 10,000 eggs in that clump of white mass. The warmth from the diver's lamp has not only kept the eggs alive, it looks like some of them are beginning to hatch. Apparently, the heat from the light has given the eggs a final stimulus, and now the tiny larvae are beginning to emerge from their egg shells by the hundreds. Thousands of baby cardinalfish have begun their struggle for survival. In the ocean, even under the watchful eye of their father, it will only be a month or so before the predators of the deep have devoured almost all of these tiny larvae, until only about a dozen will remain. If you watch in the top right corner, you'll see a fish called a four-saddle puffer approach to try and feed on the babies right through the bag. Now it's time for the divers to release the cardinalfish. They wish there was a way to protect the babies from predators, but that would only interfere with the natural cycle. Not only would the numbers of cardinalfish increase to unbalanced proportions, but the creatures which prey upon the eggs would be without a food source, seriously affecting their ability to survive. The divers must constantly stay aware of how intricately balanced life is in the ocean world. We've seen that if a species provides even a little bit of parental care, then instead of millions, only thousands of eggs need be produced to ensure that enough offspring will survive to reproduce. Now we're about to meet some other species which take even better care of their developing young. These are scorpion fish. The one emerging from the background on the right is a pregnant female. The eggs in her belly are not about to be deposited and fertilized like the majority of other fish. Instead, she carries her developing embryos in her stomach until they have grown into miniature scorpion fish, able to fend for themselves as fully functioning adults. This kind of parental protection is unusual in the fish world, but as we've seen before, any kind of extra care gives added insurance that more of the babies will survive. And that means that fewer offspring need to be conceived in order to ensure the survival of the species. The family of scorpionfish is also one of the most dangerous fish in the sea. Their top fin spines are loaded with a powerful nerve poison that can be extremely painful to its victim, and a human encounter could even be fatal. As our camera explores through the waters, we see a scorpionfish resting lazily on the rocky bottom, blending in perfectly with his surroundings. This nearly invisible fish presents a grave hazard to anyone stepping among the rocks. Because it's a relatively rare phenomenon, the divers and scientists want to study closely the delivery and emergence of living young. But the scorpionfish, though easy to capture, is much too dangerous a specimen to care for. There is another species of fish called the surf perch, found in the same area. The surf perch doesn't lay eggs either, but produces its offspring fully alive. Divers will have to set up a corral of nets to capture one because it moves much faster than a scorpionfish. Surf perch, or sea perch as they're known in some areas, belong to the perch family, though they're its only live-bearing members. The family also includes the mouth-brooding cardinalfish that we saw earlier. Live-bearing fish are unusual in the fish world for another reason. Because most male and female fish drop their fertilizing sperm and eggs separately, they don't require specialized organs to perform internal fertilization. But live-bearing fish have developed these organs so that the sperm can enter the female's body to join with the eggs, allowing her to better protect the fragile embryos as they grow. The divers have isolated a pregnant female surf perch and are driving her into the net they've set up. They take her out of the nets and put her into a plastic bag, so she'll be safe during the journey to the laboratory, where an isolated tank has been set up at the proper temperature and conditions familiar to the surf perch mother.